Hello friends, in the last video I have given you the brief introduction and explanation about the queues, various operations on queues and so on. In this video we are going to see about various different types of queues. There are three different types of queues basically. One is circular queue, another one is priority queue, and the third one is D queue. We'll go with the sequence first. First, we'll go with the circular queue. The first and foremost question arises, instead of having the linear queue, instead of having the normal queue, why there is a need of circular queue? Circular queue is a linear data structure in which the operations are performed based on first in first out principle, and last position is connected back to the first position. That's why it is called it as the circular queue. To make it seems to be like a circle, it is called as ring buffer as well. Wastage of memory in standard queue, in double-ended queue operation. What is circular queue? The arrangement of the elements from say Q0, Q1 up to Qn in a circular fashion. In a circular fashion with Q1 has following Qn. It means the first location is following to the last location is called as circular queue. In a normal queue, we can insert elements until queue becomes full. In a normal queue, we can insert the elements until the queue becomes full. But once the queue becomes full, we cannot insert the next element, even if there is a space in front of the queue, of course. If the last node is connected to the first node to make a circle, this happens only in circular queue. Initially, both the front end as well as the rear end, or the front pointer as well as the rear pointer, points to the beginning of the array. It is known as ring buffer also. Look at the diagram. In this diagram, Q0 is the initial position. We can assume it, or we can consider it as a start state. That is the front, we can say. Front is equal to the rear. This one is the front, this one is the rear, which is having the address location, say Q0. Accordingly, Q1 is there, Q2 is there, Q3 is there, Q4, Q5, Q6 and Q7. If I break this chain, if I break this ring from say Q7 to Q0, if I break over here, it will become the normal, or it will become the linear queue. As I already said, if the front end or the front pointer and the rear pointer is equal to same, front is equal to rear, or the front node is connected to the rear node, front pointer is connected to the rear pointer, is also called it as the circular queue. What are the various operations on circular queue? See, of course, it is the part of queue we can insert, and of course we can delete the elements from that circular queue. Insertion. The algorithm is given over here. In the step 1, if front is equal to 0 and rear is equal to maximum value minus 1, then the queue will become overflow exactly as if we have already seen it in the linear queue. Then go to step 4. Step 4 is exit. Otherwise, if front is equal to rear is equal to minus 1, one step behind, then set front is equal to rear is equal to 0 if we want to insert the element into that queue. Else, if rear is equal to maximum minus 1 and front is not equal to 0, set in that case, set the rear value of your circular queue should be 0. Else, increment it by 1. Ultimately, we have to perform the insertion operation from the rear end. As it is the principle of the queue. If we want to insert the new element into the queue, we always have to insert it from the rear end. If we want to remove an element, or if we want to perform the deletion operation on linear queue, circular queue, or any different type of queue, we have to perform it on the front end. Deletion takes place at the front end and insertion takes place at the rear end. So end if, and whatever the step 3 is, that is set the queue rear value is equal to r rear is equal to val. As I already said that if q0 is having the value, if these are the values 5, 10, 15, 20, 25, 30, 35, 40, in that case the insertion is not possible because there are 8 different places in the queues, in the circular queue. All are already filled. If I want to insert a new element in this circular queue, it shows me the error, and that error is queue is overflow. If front is equal to rear is equal to minus 1, as I already said in that algorithm, if front is equal to rear is equal to minus 1, then front is equal to rear is equal to 0. The reason we have to make it 0 because this is having certain value. If rear is equal to maximum minus 1 and front is not equal to 0, if rear is equal is max minus 1, whatever that maximum value, that is q7 is having the maximum value minus 1, that rear pointing towards here, and front is not equal to 0, front is also not 0, front is locating at your q1 position, front is not equal to 0. If rear is equal to rear plus 1, if rear is equal to rear plus 1, this we can implement it with the help of this diagram, and so on. Same thing if we are going to add the new element into the queue, or we are going to insert the element into the queue, we can definitely perform the deletion operation on the queue as well. The algorithm for deletion is given over here. If front is equal to minus 1, of course, if there are no any values in the queue, it automatically automatically shows you the error, or we can say it as the circular queue underflow, exactly like the linear queue. Go to step 4, exit. Step 2 is set the value is equal to q, that is front. If front is equal to rear, then set front is equal to rear minus 1. Else, if front is equal to maximum minus 1, maximum value minus 1, set front is equal to 0. Else, set front is equal to front plus 1, as we are incrementing the front since we are performing the deletion operation over here. That's it. In this case, as we all know that in the linear queue, if we are going to perform the deletion operation, the rear may also decremented by 1 if we are keeping front as a constant. Look at the diagrams over here. If the queue does not having any values in it, ultimately it shows me if deletion operation is, we cannot perform the deletion operation since it shows the error queue is empty, or it goes in underflow state. If front is equal to rear is equal to q0, we can definitely perform the deletion operation. If front is equal to maximum minus 1, then front is always equal to 0 in that case. We can perform the deletion operation over there. As we know that, as I have already said, if we want to perform the deletion operation, the front may get incremented by 1. See, firstly it deleted the value at Q2, then Q3, then Q4, then front will move to Q5, then front will move to Q6, then Q7, since rear is constant. Rear is constant. Ultimately, front may move towards this circular queue to get the proper values. Next different types of queue is priority queue. In this priority queue, as the name suggests, priority, each element is assigned a priority. Priority of an element determines the order in which the elements will be processed. It gives a certain order. There are certain rules. There are two different rules basically. An element with higher priority will proceed before an element with a lower priority. Two elements with same priority. Two elements with same priority are processed on a first come first serve basis. Then various different types of priority queues are ascending priority queue and descending priority queue. In this type of priority queue, elements can be inserted into any order, but only the smallest element can be removed if we are following the ascending priority queue. There is another type of priority queue, that is descending priority queue. In this type of priority queue, the elements can be inserted to any order, but only the largest element can be removed from that queue. Array representation of priority queue, in which while inserting the elements in the priority queue, we will add it the appropriate position depending on its priority, as if we have to give the priority first. It is inserted in such a way that the elements are always ordered either in ascending or in descending sequence. The array representation of priority queue is given over here. Whatever the priority to the given element, we have to operate on that element according to the priority first. While deletion, in the priority queue, the element at the front is always be deleted. This is the simple property of queue, as we all know. Third different type of queue is DQ, or double-ended queue. It's very simple, as the name suggests, double-ended, a list in which elements can inserted or deleted on both the end. It may be at the front end, it may be at the rear end also. This type of double-ended queue is also called as head tail link list. It has two pointers, left and right, which points to either end of the DQ. DQ can be implemented using circular array or a circular doubly linked list, where DQ n-1 is followed by DQ of 0. There are two different types of DQs again, in input restricted DQ and output restricted DQ. In input restricted DQ, insertion can be done only at one of the end, while deletion can be done from both the end. And output restricted DQ is deletion can be done only at one of the end, while insertion can be done on both the end. I hope the types of queues you got it properly. Thank you very much.